Hello ladies and gentlemen, we're going to pick up on radicals and rational exponents here. We're going to do some more simplifying problems, add some like terms, and maybe throw some fractions in there too. So let's kind of pick up here with just simplifying. Remember, it's a fifth root. I'm going to always do a prime factorization. Ooh, let's get the background. Okay, so fifth root of, let's see, 96. I'm going to divide out my 2. So 2 times 48, 2 times 24, 2 times 12, 2 times 6, which is 2 times 3, x to the fifth, y cubed. So you first have to make sure you can do a prime factorization for 96. You can make a factor tree if you want, but it's 5 2's and a 3 it looks like. So if it's the fifth root, I'm looking for sets of 5. So do I have a set of 5 2's? 1, 2, 3, yes I do. So for every 5 underneath, 1 makes it out. So now I'm going to have a 2 on the outside. Same thing with the x's. There's 5 x's, so one of them will make it out. There's only 1 3, and there's only 3 y's, so those aren't going anywhere. We still have the fifth root of, on the inside, 3y cubed. So 2x times the fifth root of 3y cubed. The second one here. So this is kind of weird. Like, if it's the fourth root of something to the fourth power, it's just going to be 562. You could imagine writing it out, 562 times 562 times 562 times 562, and be like, oh, there's a set of 4 of them. But these are inverse operations, so they're going to cancel each other out. So that's just 562. Now, the next one involves some fractions, and you can do this a couple different ways. You could simplify the top, and you could simplify the bottom, and then you could kind of deal with it. But if you have the same root in the top and the bottom, so we have fourth root in the top and the bottom, you can write it as one root. So I could put 16b in the top, and I could put 2b to the fifth in the bottom. So the reason that helps me is now I'm going to take the fourth root of, I'm going to simplify this on the inside. So 16 divided by 2 is 8 over b to the fifth is b to the fourth. Okay? Now I'm going to go back to having it as a radical on the top and the bottom and say this is the fourth root of 8 over the fourth root of b to the fourth. Now the fourth root of 8, that's 2 times 2 times 2, so there's not, you can't simplify that. It's just as simplified as it's going to get. There's not 4 2's in there. But the fourth root of b to the fourth is just b. So this is the fourth root of 8. It kind of looks like a 4 on the outside. The fourth root of 8 over b. That's simplified now. Now remember, you don't want to have radicals in the denominator, so that's a rationalized denominator as well. Now, what if we are doing addition subtraction? First thing, you can't combine different radicals. So if it's like radical 2 minus radical 3, there's nothing you can do. You have no strategies, and you never will have a strategy to simplify that. That is as simplified as it's going to get. They have to be like radicals. They have to be the same thing. So if I had 5 radical 3's and I took away 2 radical 3's, I could say that that is 3 radical 3. But that's because they have the same radicand. So first thing, just make sure you understand that unless they are the same, you cannot combine them. So these ain't the same. These ain't the same. So you can't just do this in one step. You're going to have to simplify the radicals. So 2 radical 80. So 80 is, 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. And 125 is 25 times 5. So now that we have simplified our radicals, or at least factored out our radicals, we're looking for pairs. These are square roots, so pair of 2's, pair of 2's, pair of 5's. This is now going to be on the outside, 2 times 2 is 4, and then another one, so 8. 8 radical 5 minus 5 radical 5. Wait a minute. Now they're like terms. If you have 8 radical 5's and you take away 5 radical 5's, you have 3 radical 5's. So that's 3 radical 5. If you can get a like radical, then you can combine like terms, but these were not like, so we could not. Same thing here. Let's try this one. So 2 times 2, x, y, minus y, y. We're looking for pairs. Got one, got another. So in this first term, 2x comes out, and in the second term, a y comes out. Now if you'll notice, again, we have the same radical. So let's see. You could kind of think of this sort of like a factoring thing where you're doing 2x minus y times radical y, but honestly I'm not sure that that's much better. So really, I think either of these answers are probably okay. You could probably just leave it like that. If there were numbers, we might be able to do a little bit more, but it's probably fine. All right, negative exponents. Remember, negative exponents don't mean negative numbers. They mean they're on the wrong side of the fraction bar. So you can do this several ways. What I'm going to do is first, I think for this one, I'm just going to use my exponent rules. So we're taking a power to a power, which means we multiply. Negative 3 times negative 2 is positive 6. And 2 times negative 2 is negative 4. Now your answer should never have a negative exponent in it, so we're going to say, well, x to the 6th, that's positive, he's in the numerator, but negative 4 means we need to move it to the denominator, and now it's positive. So x to the 6th, this comes to the bottom, over y to the 4th. Same thing here. You could do x to the negative 9th over y to the negative 12th. I'm getting that by multiplying the exponents. And then since they are negative, this negative goes to the bottom, and this negative is already in the bottom, so it goes to the top. So it kind of flips the fraction. Anytime you see a negative exponent, you're going to flip the fraction. On the outside of parentheses, you'll flip the fraction. You do need to be careful with that, though. 2 to the negative 10th over 4 to the negative 6th. So since the whole thing is to a negative, it's going to end up flipping. Now we have 4 to the 6th over 2 to the 10th. So we could simplify this. If we wanted to make them with the same base, we could probably do it quicker. Since 4 is 2 squared, I could write that as 2 squared to the 6th over 2 to the 10th. And then I can use my exponent rules to say, that's 2 to the 12th over 2 to the 10th. And if you have 12 2's in the top and 10 in the bottom, you would cross out 10 of them. You would have 2 left in the top. So this whole thing, believe it or not, is 4. That's cool. So that simplifies quite a bit. One more, 3 to the negative 4th, 4 to the positive 6th. So 4 to the 6th will stay in the top, 3 to the 4th goes to the bottom. And these are not the same base. 4 and 3 are not the same base. So I'm not going to be able to do a whole lot here. But I could simplify 4 to the 6th, which is 4,096. And I could simplify 3 to the 4th, 3, 9, 27, 81. So 4096 over 81. It's not going to reduce. That's the best you can do. So when you see negative exponents, that means I'm on the wrong side of the fraction bar, and you should never have a negative exponent in your answer. So a couple more problems to practice here. Let's see, simplify each. So now we got some fractional exponents. So you could do this several ways. What I'm going to do is first combine the numerator. But to do that, you got to remember, like, this is an exponent rule. If you have x squared times x cubed, that's x times x times x times x times x, which ends up being x to the 5th. So you add. Well, if I want to add these two, I need to get a common denominator. 2/5 plus 1/3, those aren't the same. So I'm going to give this guy multiplied by 3 in the top and the bottom, and this guy by 5. So I end up with 6/15 plus 5/15, and that's 21 over 15 in the top. Yikes. And then a to the 3/2 in the bottom still. Well, those aren't like terms, and I want to subtract them. So let's see. 21 over 15. Well, let's see. Let's get a common denominator between these two. I'm going to use a to the, well, I can just write the fraction part. Let's do 21 over 15 minus 3/2. So we'll get a common denominator again. So double this guy, multiply this guy by 15. That's 42/30 minus 45/30. So we end up with negative 3/30. So this is a to the negative 3 over 30, which can simplify to a to the negative 1/10, which I can then write as 1 over a to the 1/10. And that's going to be your best answer, 1 over a to the 1/10. Or if you want to write it as a radical, that'd be the 10th root of a. Both of those would be fine. But that's a little tougher because I had common denominators. Let's do another one. I'm going to take a power to a power. So this would be 20. Let's try and work smarter, not hard here. I think I'm going to simplify the fraction first. I could do the cube root of the top and the cube root of the bottom because that's what 1/3 is. But I think if I simplify this, it makes it easier. So I'm going to simplify the inside. 24 divided by 3 is 8, and a to the 4th over a is a cubed. Yeah, that's a lot better. So now I'm taking the cube root of 8a cubed, which is really easy because 8's a perfect cube. That's 2, and a cubed is a perfect cube, a. So this comes out to just be 2a. All right, so looking good. Few more. Let's see. Since these are different, 1/2 and 1/3, you cannot simplify them. You can't do anything with the inside because they're not the same radical. But we can simplify the top and we can simplify the bottom and see what happens. So this is a square root. Now I'm going to do this in my head, but let's think of it in terms of exponent rules. If you know it's square root, the square root of 64 is 8. But now let's use our exponent rules. 6 times 1/2 is a cubed because there's 3 sets of 2. And there's 4 sets of 2 if there's 8 of them. So 8 times 1/2 is also 4. Same thing here. The cube root of 8 is 2. The cube root of a cubed is a because 3 times 1/3 is 1. And 6 times 1/3 is 2. So this ends up being 8 divided by 2, which is 4. You could cross out one of these and you have 2 left in the top. You can cross out 2 of these and you have 2 left in the top. So 4a squared b squared. Okay, looks good. Way better than what we had. Let's use our exponent rules. 1/2 times 2 is 1. 3 times 2 is, well, 3 times 1/2 rather is 3/2. 1/3 times 3 is 1, and 1/3 times 3 is also 1. So those are both going to have 1s. Now we can combine like terms. So when you multiply, well, it's not really like terms, but x times x is x squared, and then y to the, so think about how many this is. This is 2 halves. That's 1 whole. So 1 is 2 halves, and here you have 3 halves. So when you add those together, you have 5 halves. So x squared times y to the 5 halves. Exponent rules, x to the 3 halves, y to the 3rd. That's pretty much all you can do here. Okay, 3 times 1/2 is 3 halves, 6 times 1/2 is 3. And we'll do one more, so let's focus on these two first. So well, the 3 is the only coefficient, so it's going to be a 3 out front, and then we'll do the a's. So how many a's do I have? 2/3 plus 1/3 is 1. 3/4 plus 5/4 is 8/4. So that's 3a, 8/4 is b squared. So 3a, b squared. Okay? So make sure you have worked on your Khan Academy exercises for all your radicals and rationals, and that's some slightly more difficult problems there, but that's it for A1. So good luck, and be sure to hit that like and subscribe button.